Okay, this is section 1.3, solving equations. And the first thing we're going to look at is when writing algebraic expressions, we're going to be looking for keywords. More than, okay, we know that more than means add, but we're going to switch the order of the numbers as they come in the expression. And I'll show you what that looks like. Less than means subtract. I don't know why I put add there. You need to change that to subtract. Okay, because less than means we're going to subtract and we're going to switch the order. Quotient means divide. Product, remember, means multiply. Squared means it's something to the second power. We're using exponents. Cubed means something to the third power. And anytime we see the word is, we're going to put an equal sign. So let's look at example 1. Example 1, the instructions say, write an algebraic expression to represent each verbal expression. So we have two, I'm going to underline our key words, more than, we have the word times, and we have the word cube. All right, so I see 2 more than 4 times the cube of a number. All right, so first of all, more than means I'm going to add, but instead of putting 2 plus 4, I'm going to switch that order. Okay, so let's do this first. 4 times the cube of a number. If I don't know what a number is, I'm just going to write an X to take its place. I don't know what just happened there. So 4 times the cube of a number, here's my number, I'm going to cube it, and then I have to write 4 times that. So here's 4 times the cube of a number, x cubed, and then I want 2 more than that. So 2 more than means I'm going to add 2 to it. So do you see 2 more than? I put that plus 2 at the end instead of at the beginning. That's what I mean by switching the order. All right, so that's my answer, 4x cubed plus 2. All right, let's do B. The quotient, so there's a keyword, of 5 less than, there's a keyword, a number, and 12. So the quotient means I'm going to divide, and when we do divide, most of the time I'm going to write it as a fraction bar. Okay, instead of writing divided by, I'm going to use the fraction bar as my division symbol. So the quotient of 5 less than a number and 12. So 5 less than a number. That's what I need to write first. Less than means subtract, but instead of writing 5 first, I'm going to write my number first. So my number is x, because I don't know what it is, minus 5. And then quotient means divide, so I'm going to divide that by 12. So the quotient of 5 less than a number and 12. X minus 5 divided by 12. C, 3 times the difference of a number and 8. So 3 times is a keyword, difference is a keyword. All right, so I know difference means subtract. So 3 times the difference of a number and 8. So I know I'm going to have to subtract x minus 8. And when I do that, I'm going to put parentheses around this x minus 8 because it's 3 times this whole difference. If I just put 3x minus 8, that's different than this because when I distribute out, I'm going to get 3x minus 24, which is not the same thing as this. So 3 times the difference of x minus 8, and that's my answer. So anytime you have the difference of something and you're multiplying by a number, you're going to put that in parentheses. All right, so let's look at example 2. Okay, so now we're going to talk about equations. A mathematical sentence containing one or more variables is called an open sentence. All right, and a mathematical sentence stating that 2 mathematical expressions are equal, that is called an equation. So what makes something an equation? It has an equal sign. So write a verbal sentence to represent each equation. This is where they want us to go backwards and use our keywords. So however you want to do it, there's lots of correct answers. I don't want you to say g minus 5 equals negative 2. Okay? I want you to say something different. I want you to word it differently. So I have a subtraction problem here. I could use the word difference. So I'm going to write the difference of a number And 5 is, because is means the word equals, negative 2. Okay, that's one way I could write g minus 5 equals negative 2. Okay, let's look at b. 2c equals c squared minus 4. So on this one, I could say 2 times a number is, and you can go ahead and say is equal to if you want. This is subtraction again, so I could go ahead and use the difference of, and how do we want to say this? That number squared, since it's c squared, of that number squared and 4. Okay? All right, next example. Okay, and these are the properties that we've been going over in class with our card game. All right. The reflexive, symmetric, transitive, and substitution property. We've already talked about these. Remember, reflexive, you get the exact same thing back on each side of the equal sign. Symmetric takes the what's on the equal sign and trades places with it. So 18 equals negative 2n plus 4 is the same thing as negative 2n plus 4 equals 18. The transitive property, remember, you have the first thing is equal to the second is equal to the third, so that means the first and third have to be equal. And then we have the substitution problem. So let's look at A. If 3a minus 4 equals b, and b equals a plus 17, then 3a minus 4 equals a plus 17. So do you see that I have the first thing equal to a second thing, the second thing equal to the third thing, and then they're saying, okay, the first thing has to be equal to the third thing. What property is that? That's going to be the transitive property. Transitive. Okay, B. If 2g minus h equals 62 and h equals 24, then 2g minus 24 equals 62. Do you see that they took this 24 and substituted it in place of that h? So that is substitution property. And C. If negative 11 plus 2 equals negative 3a, then negative 3a equals negative 11a plus 2. They're saying the exact same thing, but they've switched the order. They put what was on the left on the right. That is the symmetric property. Okay, so let's look at example 4. Solve each equation, check your solution. And they give us the addition and subtraction properties of equality and multiplication and division. Remember, this was also in our card game, but it also basically says that, remember back in Algebra 1, whatever we do to one side to keep the equation equal, we always have to do to the other side. So on A, I'm going to solve for n. n minus 3.24 equals 42.1. So I'm going to find my variable. They're subtracting 3.24, so I'm going to do the opposite and add 3.24 to both sides. So these will cancel. I have n equals. When you're adding decimals, remember you have to line up the decimals. So this would be 3.5, so 45.34. Okay, it says check your solution. We can check by plugging this in back into my equation. So 45.34 minus 3.24 should give me 42.1. And when I subtract those, it does. Okay, so let's do B. 2/3 y equals negative 18. So I want y by itself. That means I have to get rid of whatever's next to my y. So I have 2/3 times y. So to get rid of that, normally I would divide by 2/3. But way back in elementary school, we learned that we really can't divide fractions. So we're going to multiply by its reciprocal. Okay? Remember the reciprocal is 3 over 2. Take this fraction, flip it over. And remember, this is also called the multiplicative inverse. So now all of these will cancel, and I have y equals. Now remember how we multiply fractions. We don't have to worry about a common denominator. We're just going to multiply straight across, or you can see if you can cross cancel. I can cross cancel my 2 with my 18. This becomes a 1, and this becomes a 9. So negative 9 times 3, negative 27 over 1, or just negative 27. And that's my answer. And again, to check, I'm going to take my answer, plug it in for y. So I have 2/3 times negative 27 equals negative 18. So let's see if that works. This is negative 27 over 1. I can cross cancel. That's 1. This becomes 9. So 2 times negative 9 is negative 18. Okay, example 5. We're going to solve. Okay, this time they've put some parentheses in here, so we're going to have to use the distributive property. So I'm going to say 5 times x, 5x, plus 5 times 3, 15. Now I'm going to do the same thing with my 2. 2 times 1, 2. Remember, this is negative x. So 2 times negative x is minus 2x equals 14. So now I need to combine like terms. I have a 5x and a negative 2x. So that's going to give me 3x. I have 15 plus 2, so that's 17 equals 14. So now I have to get x all by itself. So I always find my x covered up, okay, and I want to get rid of anything that's next to my x. So the first thing I have to do is get rid of that 17. So subtract 17 from both sides. I want you to show all of your work. So then I have 3x equals 14 minus 17. That would be negative 3. To solve for x, it's 3 times x, so I'm going to divide by 3. So x is equal to negative 1. And we could check this by plugging negative 1 back in and see if we get 14. I'm going to do that real quick. So I have 5, negative 1 plus 3, plus 2, 1 minus negative 1, and that should give me 14. So that's 5 times 2. 1 minus negative 1, that's going to be 2. So 10 plus 4 is 14. All right, example 6. The formula for the area of a trapezoid is A equals 1/2 h times the sum of b1 plus b2. So this is the formula for the trapezoid. H is for the height, and b1 and b2 represent the measures of the bases. So instead of just using different variables, they decided to use b for both of them because they both stand for a base, and so they numbered it. And a lot of times I'll call this b sub 1 plus b sub 2. All right, so I'm going to write this down here, and we are supposed to solve for b sub 2. Okay, so if I'm solving for b sub 2, first of all, the first thing I see is this fraction. And I know a lot of times you guys don't like fractions, so I can get rid of this. And the way I'm going to get rid of this, since it's 1 over 2, I'm going to multiply everything, both sides, by 2. So when that happens on the left-hand side, I have 2 times a. And then do you see that this 2, because this is over 1, this 2 and this 2 now cancel each other out. So what do I have left? I have 1h, and usually I don't put the 1 there. I'll just put h, b sub 1 plus b sub 2. Okay, now there's lots of ways you can finish this problem. I know that I have to solve for b sub 2. So I'm going to have to get rid of everything else. So the first thing I'm going to have to get rid of is this h, because this h is being multiplied times this sum right here. So if I want to get rid of this h and it's being multiplied, I'm going to divide both sides by h. So now I'm going to write down what I have left. 2a over h equals, these h's cancel, and I have b1 plus b2. Now that makes it look really easy. If I'm solving for b sub 2 and b sub 1 is being added to it, I need to subtract b sub 1 from both sides. Now, I know it looks kind of weird, okay, but when I subtract b sub 1 over here, on the right-hand side, I have b sub 2 left. And right here, the way I would write it is just 2a over h minus b sub 1. Okay, last one. Example 7. If 6x minus 12 equals 18, what is the value of 6x plus 5? So this one looks a little different because they're not asking you to solve for x. They want to know what 6x plus 5 would equal. So this is where we can use what we call those properties of addition, addition of equality, and subtraction of equality. I want, and I'm going to write this down right here, 6 minus 12 equals 18. I want this side, instead of being 6x minus 12, I want it to be 6x plus 5. So what am I going to have to add to negative 12 to get it equal to a positive 5? Do you see I'm going to have to add 17 to that? Negative 12 plus 17 gives me 5, and that's what I want over here. So I'm going to add 17 to both sides. Can't add it just to one side because I have to keep everything equal. So I'm going to add 17 to both sides, and now here's what I have. 6x plus 5 equals 18 plus 17, 35. So what is the value of 6x plus 5? 35. Okay. Your assignment for 1.3 is going to be page 22 and 23, 2 through 50 even, and I will see you tomorrow.